have a meeting on Thursday morning at 8:45. Please spread the word to the seniors who are not here when announcements are made in the morning. It's an important meeting for seniors, so make sure that you spread the word that it'll be Thursday morning at 8:45 a.m. There'll be several announcements about senior activities for the spring. All right, that's all the announcements for today. If you would, please stand. Salute. Pledge allegiance to the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, so, tonight work, and, yes. Until you have Robert or something, let's see,
How are you doing today?
I got everybody there. Here. Alright. I want to see your work. Hey. Don't put it up. You guys don't make me tell you, okay? The Valerie just automatically get up.
One through 16.
No, I did 16, 18, 19.
So I didn't do.
So waiting for it to be out. Your English assignment, Jonathan, what else?
He just pulls out his research paper. All right.
I don't have English.
Bro, where's my name?
What?
Put it right there so she can see it. Oh, I didn't do 22.
He said your hair was fake. He said your hair was fake.
Oh, and you did that. So I didn't do 4 problems.
Why not, bro?
I forgot how to do these 2. It was like,
Okay, so I'm gonna answer some questions about some of the problems. Let's see, this is 15.3.
What's the answer?
Oh. Okay, I know that. I need to do this one. This is 18 and 19. And 18.
I think that's the proper street.
No.
It's too yellow. In another one? Oh, yeah. We've seen Endgame, and the colors cool. Yeah. No, Avengers Endgame.
Okay, so, the first thing 18 asks, the first thing 18 asks is about M, angle M, okay? So, I'm gonna put an X here. And then the other thing it asks about, 19, asks about this right here. I'm gonna put a Y there. Okay? All right? Now, K and C is the central angle, right? K is the circumscribed angle, okay? So those two things are supplementary, which means this is 140 degrees. Okay, you see that? Now that means that this arc is 140 degrees. Central angle. Oops, I don't want to do that in blue. Central angle and the intercepted arc are the same measurement, right?
Mm-hmm.
Now, an inscribed angle and its intercepted arc, what's their relationship?
The angle is double to make
The arc is double the angle.
oh yeah.
The angle is half. So angle M equals 70 degrees. Well, I covered up around 140 there. Okay? You see that?
Mm-hmm.
Now, I know that this piece let's see. Right here, this arc is 140, right?
Mm-hmm.
I know that this arc is 138. So this Y is what I need. So how do I find that?
You add both of those together and subtract that.
What?
You add both of those together and subtract that number from 360.
Right, 360 minus 140 minus 138 equals something. 278, 27, is that like 92? 82. Okay. Did that help?
Sure did.
Oh yeah, I think I got it right here. Help with 22.
Oh, number 20?
22.
22?
Was it 20 or 22?
Okay, 22. In the figure, QP and QR line. Okay, now I want you to pay attention to the labeling. All right. So a lot of times I read through it without saying it, and then I go back. Have you noticed it? Because I need you guys to realize that this is talking about line QP and line QR, and it's telling you that they're tangents. Okay. So a student was asked to find angle PSR. And so it's got the X labeled there, doesn't it? And so they say since PQR is a circumscribed angle, and I want to talk about each one of these things. Is angle PQR a circumscribed angle? Okay, circumscribed angle, yes, you're right, it is. It's outside the circle, so it's a circumscribed angle. And then it says angle PQR and PCR are supplementary.
Yes.
Is that true?
Mm-hmm.
Yeah, it's talking about this angle right here and this angle right here, right? And in fact, instead of me doing that, PQR and PCR, okay? Okay, so they're supplementary, right? So if PCR is 110, okay, I'm gonna make it bigger. You guys will have to help me here in a second. Oh, I guess I can put it online. Okay, in my book. Okay, so PCR is 110 degrees. Okay. And then it says, because this is 70 degrees, right? Okay, so far his logic is right? All right, now it says, since PSR is congruent to PQR, PSR is 110 degrees. It says that PSR and PQR are congruent. So what should PSR be?
7.
Yeah. Well, it's not even true, but that's not true either, but sorry. But do you see that even what he said though is wrong? He said, or is it a he? I'm saying it, a student. He said that this angle was congruent to this angle and then called it 110 degrees, which was even wrong from what he said. Does that make sense? Do you see what I was trying to say?
Yeah.
Oh, okay, but that isn't even right. What?
It says PCR is 110.
What says what?
It says PCR is 110 instead of PSR.
Oh, yeah, my book doesn't. That's why y'all are looking at me like that. My book says the other two are congruent. Okay, so he's got his work right. It's just that he thought wrong. Okay. All right, so we know that angle PCR is 110 degrees, right?
Yeah.
Okay, I'm gonna draw another circle. And then I'm gonna draw the central angle. And I know that it's 110 degrees, right? If that angle is 110 degrees, how much is this arc? What is it? 110 degrees. Now remember, that last problem I just did does the same thing. You have to remember from 15.1 that a central angle has the same measurement of its intercepted arc, right? Same measurement of its intercepted arc, okay? An inscribed angle, which means the vertex is on the circle, is half the arc that it intercepts, okay? It's half of the arc that it intercepts, okay? So, what's the rest of this circle? What's from here to here? What? 250. And how did you find that?
360 minus 110.
Okay. All right, so do you guys see that? Okay, so now let me, from here to here, let me erase this. From here to here is 250, right? Now look here. What is this angle right here?
125.
What's it called? Inscribed angle, right? And an inscribed angle is half of its intercepted arc. And remember, that's that part I called ice cream, and y'all were like, oh, what are you doing with it, right? So this is 125 degrees because it's half of the intercepted arc. So it looks just like that red circle I drew, and I'm gonna draw another one. An intercepted arc, inscribed angle is half of its intercepted arc. Okay? And I've actually got, I think tomorrow I have 4 different pictures to show you that talks about inscribed angles and central angles, and okay, and that they can be placed a little differently and look differently. So I've got 4 different examples to show you tomorrow of just how different and they are, and when they can have the same arc. Okay, but we'll look at that tomorrow. All right, so does that answer that question on 22?
Yeah.
Any other?
Lesson practice number 4.
What?
Lesson performance task number 4.
Number 4?
No. I went around right, and I filled here, so I'll say right.
Okay, oh, you said task part 4. I heard 4. I just heard 4. Okay. All right. So 4 is how fast must it travel to complete a revolution in 24 hours? Okay, so I'm gonna have to work through the whole thing though. Okay. Probably somebody else needs the whole thing anyway.
Yeah. Probably we would want to.
Okay, now it tells us that this is 9 degrees, right? Doesn't it say that in there somewhere?
Yeah.
Yeah.
Okay, it tells us that's 9 degrees. And yesterday, when I drew that picture on the board, when I drew this and we labeled it, these 2 guys are supplementary, right? And we figured out that those were 2 congruent triangles, didn't we? Right? Why? Why were those 2? What was the theorem we used to prove that those were 2 congruent?
Something.
Hypotenuse leg.
No.
So when we look at these, I know that these 2 angles are congruent because that triangle on the left and the triangle on the right are congruent triangles, aren't they? Are you guys paying attention to me? Okay. All right, and so I also know that this is 4,000 and this is 4,000. Why do I know that? Yes. This is radius, and this is radius, and this is a radius, right? How many radiuses are there in this circle?
30.
I mean, yeah, there's 3 drawn radiuses, but how many radiuses? There's infinitely many radiuses, right? Okay. So do you see though that, I'm gonna draw it out here. and this is a right angle, right? This is 4,000, and this would be 26,000, right? Okay? Yeah? Now I also know if that's 9 degrees, this angle has to be 81, doesn't it?
I guess.
Or, okay, let's do it this way. Hang on. We can do it this way. I'll do it 2 ways. And this is 81, okay? Hey, you guys, I don't know why there's any talking. I don't know why eyes are not rapidly up here watching me do this problem. Now, but what do you guys like to come up here and do it instead?
No, because then it'd be wrong.
So why are you not paying attention to me while I'm doing it?
My fault.
Now, so do you see this big angle is 162?
Yes.
Okay, and I'm gonna do it one other way. If this angle out here is 18 degrees, sorry. Now, do you see my circumscribed angle and my central angle? Okay, the circumscribed angle is 18 degrees. So what's the central angle C down here gonna be? 162, because it's gotta be this angle and this angle are supplementary, aren't they? Okay, so do you see I could figure out what that was 2 different ways? And so this is 162. And if this angle is 162, this arc is 162. From B to D is 162, right? So when it talks, we know that that is 162 out of 360 degrees. Somebody give me a percentage there. I mean, what's 162 divided by 360?
Divided by?
Yeah.
45%.
What?
45%.
45%. So it's 45% of the circle. And if I had drawn a diameter through it, how much of the circle would that be? If I drew a diameter right here, how much would all that be? 50%. So do you see that 45% kind of makes sense, doesn't it?
Mm-hmm.
Okay, so it's 45% of the radius, isn't it, that we've got to find. So,
45 degrees.
pardon me?
Yeah.
You put 45 degrees. Instead of 45%, you put 45 degrees.
I just 45%.
Wait a minute. Percentages.
45%. Okay, so now we know it's 45%, and then what? I don't even remember what I'm answering.
We were finding the length of AB for the first one and then second one.
Yeah.
How much longer did it for each one?
Okay, so we're doing circumference.
No, I thought we were doing AB.
Well, she asked me about 4.
Oh.
That's what I was doing, was 4.
You said
So,
you do all of them.
what?
You said you do all of them though.
Well, I wasn't really paying attention to, I figured I was gonna hit all of them is what I figured, trying to get down to 4, but I guess I didn't. Do I need to do 3? Is that what you're telling me? Okay, so okay, I answered 2. I just answered 2, didn't I? All right, I see where I am. So then it says, how much longer does the satellite signal take to the satellite signal to reach a point B than it takes to reach point E. Use 186 miles per second. As the speed of a satellite signal. Okay, so I have to find the length of AB, okay, to do that, because I know from A to E, it's 22,000 miles, right? Okay, so I'm going to use Pythagorean theorem, 4,000 squared, plus I'm going to label that x squared equals 26,000 squared, okay? When you solve that, what do you get? X equals what?
25,690.
25,690. Okay? Okay, so the difference in distance between A to E and A to B is, I'm going to subtract 22,000. And I get 3,690 miles further. Does that make sense? The point B is 3,690 miles further than point E.
Oh, yeah.
Right? Because A to E is 22,000 and A to B is 25,690, right? So the difference is that. So, then, how fast is it traveling? 108. Okay, so I'm going to divide 3,690 by 186,000. And I get 0.02 seconds. So, isn't it crazy? It doesn't even take a full second for that signal to go 3,700 miles further.
Wowzers.
Okay? Okay, now 4, right? It's a good thing I have you guys to keep me on track. 4 is circumference. Okay, so 4 is 2 pi r. And r's not squared because my answer won't be squared. Remember I told you guys you can remember it that way, the formulas? And I have 2 and pi and my radius.
It's 4,000. Well, now.
Is what?
4,000.
4,000. I'm tripping. I'm
Yeah, my book is wrong. 4,000 is the radius. Okay, my answer's wrong in here. Did you look? Is that the book put 26,000. So, no, the book's right. The book's right.
Wait, whoa.
Okay, let's think about this. Because this is kind of interesting. The book is right, it's 26,000. Remember, what we're trying to find is orbit, right? So this satellite, A, is swinging all the way around. It makes a lot bigger circle than the Earth. So the 26,000 is the radius from the satellite to the center of the Earth. And that's the circumference. That circle is the circumference you gotta find. That almost got me too. And then I'm not gonna, let's see, I'll write down the answer. I'll cheat. Let's see, the answer is gonna be 163,280 miles. Okay, and then you're just gonna divide that by 24. It's gotta do that in 24 hours. Does that make sense? So you just divide it then by 24 hours?
What do you get?
The part
scholarship from Kentucky, Greg?
It takes it 60.
Yeah.
Okay, okay, what? It should be 6,803 miles per hour. It just rounded it to a whole number. I also need to do, I also want to do 8, by the way, again. I know I did it yesterday, but I really want to cement in your head about radiuses and looking for them, okay? So this wants us to find QT, all right? So I know that this is a right angle. So QT is my hypotenuse, isn't it? Now, I think that's another tricky thing about these. It doesn't really look like a hypotenuse. So write in those right angles. Write in, with the W, those right angles, okay? And remember, your hypotenuse is always directly across from your right angle that you've written in, okay? So I know that this is 5 too because it's also radius. And I'm just going to scribble out that 5 now because I don't want it, I just want to look at QT as a whole. That's my X. So it's simply Pythagorean theorem at this point. 12 squared plus 5 squared equals X squared. Okay? Any others? What?
She's at 3.
3. I'm sorry. Okay. Okay, let's make a conjecture, okay? Just a hypothesis in science class. That's about the tangent lines. So M and N are the tangent lines. And I know that the central angle, okay, and the circumscribed angle, these two angles are supplementary. And so that central angle is a 90-degree angle. Then where my two tangent lines intersect is also going to be a right angle. It's also going to be a 90-degree angle, okay? And that's all there is to that one, all right? Any others?
11.
What?
11.
Crazy. I did this so late at night, I forgot that.
Okay, that's just simply that they're supplementary. That's it. That's all I wanted there. I know you're like, okay, we just said that. Does it really want me to say it again? Yes, I'm trying to, it's just trying to cement that into your head. Okay? So right now, we've got 3 angles that we're talking about. We've got a central angle.
Circumscribed.
Okay? We have an inscribed angle. And gonna pretend that that's a tangent line, though I missed my circle a little bit. And a circumscribed angle, okay? I know that my central angle is the same measurement as the intercepted arc, okay? I know that my inscribed angle is half of the arc of the circle that it intercepts, okay? Is there anything else right now before I go on the 15.4? And I have 15.4 and 15.5 up there, but I think I'm just doing 15.4 today because it's already 10 after. Tomorrow I'm going to give you, I thought I was going to do it today, but I am not going to get to it today. So tomorrow I'll give you 4 circles and we're going to do some labeling and drawing of our own. Okay? All right, 15.4. Okay, what 15.4 is segment relationships in circles. What are the relationships between the segments in circles? That's what we're looking at today. What's the relationship between the segments inside the circle? Okay, what kind of segments are inside of a circle? What would we call them? Chords. Radiuses. Diameter. Now, is a radius a chord?
No.
Why is it not a chord? What? Right. Okay, so a radius, both ends don't lie on a circle, do they? What about a diameter? Is it a chord?
Yes.
Yes. Both of its ends lie on the circle, so yes, it is a chord. By the way, I'm supposed to get observed this week, and you know it doesn't bother me about food or drink in here, but it does bother Mrs. Stone. So if she happens to come in here, you are going to have to not bring in anything but water. Put it away. You'll have to put it away. Okay?
That means no. It's okay. Just put your chips in your bag.
Yes.
Never know.
Okay? By the way, alright, so, and I don't know why that just popped in my head right now, but, alright, so let's look at page 816. And I won't either. You guys have to put it away, I'll have water too. That might go into shock because my body won't know what to do with it, but it'll be alright. I'll survive, I guess, right?
Does gum count as food?
Huh?
Does gum count as food?
I-
Does gum count as food?
No.
Okay.
Okay. Chord product theorem on page 816. Now I want you to first, before we do anything, I want you to look at that angle. Is that where E is? Is that a central angle?
No.
Is it an inscribed angle?
No.
No. Is it a circumscribed angle?
No.
No, it's just floating out in the circle, isn't it? It's not on the circle, it's not in the center of the circle, it's just in the circle is all, okay? So, you gotta pay attention to that, because that makes a difference, okay? So now, what this is saying is if two chords intersect inside a circle, then the products of the length of the segments of the chords are equal. So it's saying AE, and I'm going to label this A, times EB equals CE, and I'm going to label that D, times ED. And this is one of my favorites. I know I'm not supposed to have favorites, but this is one of my favorite theorems. Because it's so easy. I think it's kind of cool to think that it works that way. You know, that you can multiply those two things together and those two things together, and it's equal. To me, that's just mind-boggling that it works. And I don't care what the chords look like. If you have a circle, and I have a chord here and a chord here, it still works the same way. That part, one part times the other part equals, it always works. It is really kind of neat. What?
My brain doesn't grasp this yet.
Well, and the reason why this works is, think about like 1 times 7, and I'm not going to pick equal ones, but 1 times 7 is 7, right? 2 times 3, where they're closer, it's going to be 6. It gets close. Do you see? And that's why, because you got it here. You'll have a small number times a big number, but here you got just 2 close together numbers, and that's why it works. But it's I guess I'm just that's my nerve. So flip the page, and we're going to do these. So on page 817. I'm doing 6 times 2 equals 3 times x. Piece times piece equals piece times piece. Okay? So I get 12 equals 3x. So 4 equals x. And that's all there is to this one.
No, this is a flash to the pad. Easy.
So let's look at,
okay.
Let's look at the one at the bottom. It says to find the value of x. And it says AD is 12. If AD is 12, what is ED?
ED is
9, right?
It is 9.
This would be 9. So I got 3 times 9. And I'm actually going to do it this way. 3 times 12 minus 3 equals 14 times x. Okay, right? Do you see? I just wanted to label that in case that happened to be the x. But all we did to find 9, we did 12 minus 3, right? Because it told us this whole thing was 12. Does that make sense? Is everybody with me? And then we got 27 equals 14x. So x is going to equal about 1.93.
Oh my goodness. How do you...
Now it says to find the length of each chord. Okay, so be careful what the directions are looking for. So chord CB is actually going to be 15.93. I added that 1.93 to the 14, right?
Yeah.
We already know what the other chord is. It's 12. Okay? And I think we got one more theorem in this. Oh, 2 more. Oh, it's a good thing that I'm not doing. Okay, so next chords. Some more words. A secant is any line that intersects the circle in exactly 2 points. Do you see the difference in a secant and a tangent?
Yeah, because it touches that A and B.
So, if 2 secants intersect the exterior of a circle, then the product of the lengths of the one secant and its external segment equals the product of the lengths of the other and its external segment. So what we have here is outside
Versus the whole.
times the whole equals outside times the whole.
But,
Okay? So where is an example? On the next page.
This seems so easy.
819. Now, what's the whole of AE?
AE is 12.
Okay, so I have outside times the whole equals, and it doesn't matter which one you do first, does it?
No.
I'm abbreviating over here. Because order doesn't matter in multiplication, does it?
No.
So, I just like the way that flows, is why I always say outside. So I have 6 times 12 equals 5 times what? What's the whole on CA?
5x.
What is it?
5x.
Okay, so
5
this,
plus x.
huh?
5 plus x.
This is where 5 plus x, or we can write x plus 5. Okay, this is the only hard part about this theorem. Okay, you gotta be really careful that you're not saying 6 times 36. 5 times 5x, okay? That, and I'll do it too. It's really easy. You gotta remember you're adding to get the whole, okay? All right? You'll catch me doing it too. It's just easy to do that. So I get 72 equals 5x plus 25. Oh, my 25 looks funny. So subtract 25 from both sides. And I get, what, 47?
Yep. Divide it by 5.
And of course, it's going to be a decimal. 9 point something.
9.4.
9.4?
Good.
Yes.
2 times.
Now, the directions also say find the length of each segment, but I'm just going to stop for x so we can go. Okay?
Do one more.
Do one more?
No, there's one more theorem.
Do you want me to do another one of these?
I got it.
So she's practicing. Extra.
All right, so the difference of the next one, if you go to the next page. Okay, it's a tangent and a secant, right? But there's no difference. Outside times the whole equals outside times the whole. Because look, what it's saying here is outside times the whole equals the outside squared. But the outside is the whole thing on this one, isn't it? So I taught you one thing, outside times the whole equals outside times the whole for both of these things. Instead of remembering each one, it's always just outside times the whole equals outside times the whole. It's just in this,
Times with 7.
yes, because it is the whole thing now, isn't it? Does that make sense? The outside is the whole. So let's look at an example. Let's look down here at this one. Bottom of page 820.
Here.
So outside, look at, I'm even gonna abbreviate even more. Outside times the whole equals outside times the whole. So outside times the whole. You see what I did for AB? Equals outside times the whole. And I'm gonna put up here, this was AB, and this was BD. Alright? So I get 25 equals 2x plus 4. Okay, subtract 4 from both sides. I get 21 equals 2x.
10.5.
Divide by 2,
10.5.
10.5.
10 and 5, 10. Get it right.
Okay? So you got 3 things in this section. You got piece times piece equals piece times piece, right? The 2 chords. You got outside times the whole, and the third thing is outside times the whole is outside times the whole, right?
Yeah.
Look at the number 9 on the 821, and this will be the last one I'm doing.
Oh, you said, I'm that like translated.
Okay, on a bird watching trip, you travel along a path tangent to a circular pond to a lookout station that faces the hawk's nest. Given the measurements in the diagram on your bird watching map, how far is the nest from the lookout? How far is the nest from, okay, so it's got an X, labeled X already, doesn't it? So I'm gonna set this up, how?
Outside times the
Yes, outside times the whole equals what? Outside times the whole, right? So, give me one side.
25 times.
25 times what?
Well, 25 times x plus
25 times X. I don't have to add them together because X is the whole thing. It's standing for the whole
Oh.
thing, isn't it? You guys see that?
25.
Equals what?
100 times 100.
Yes. Outside times outside, right? The whole thing. So I get 25X equals 10,000?
Yes.
How did you do 100 times? Why was it 100 times 100 again?
Because it's outside.
This is gonna be this problem. Do you see it? Here's my circle.
Yeah.
Do you see it now?
Yeah.
And if I divide 10,000 by 25, is it 400?
Yeah.
400 yards. Okay? What do you think? Good?
Yeah.
Let's look at what problems I want you to do. Okay, so I want you to start at 5.
Times a lot.
5 through 18, I want you to omit 12. It's complicated, a little bit more complicated algebra that I want to do with you guys. And then I got 20 and 21.
5, 3,
Okay?
18, 20. Did I just mark out 12?
Yeah.
Alright. Yeah, but sometimes when they say omit, hey, make sure, I didn't say X it out. I just said omit it. Huh?
Is it, wait, it starts on what page again?
Okay. Yes, 823. Okay? So how many want to go back to
Can
triangles?
I take a picture of it?
Yes. Of course, you don't ever have to ask me. If if you can take a picture of something I've written on the board. If you're taking a picture of me, then yes, you should get my permission, anybody's permission, but
You wanna take a
board,
selfie? Thank you. I got one Mr. Carter too before he left.
alright, so we have about 35 minutes, so you might have a little bit of homework tonight. Okay? Okay?
Yes, ma'am.
Yes, ma'am.
My brain's not. Doesn't this make you wanna cry?
Aww. Oh, and he came by yesterday.
Are you serious?
Yeah, after school we had to have a meeting, and he left me an invitation to his wedding. Well, save the date. Mr. Carney?
Wait.
He has a wedding?
What?
He got a girl.
Yeah,
He's, hey,
Wait,
have you seen
I don't
Mr.
understand.
Allen? Yeah.
I just know.
Oh, yeah.
Like, it's
This.
profile right here.
You look like
Because M is a midpoint of PQ, doesn't give you measurement of PQ.
M is the midpoint of PQ,
Is that when y'all?
so it's X times X.
Yeah.
Okay, alright, look at 7.
Okay, so what do you
Look at 7 real fast.
What number?
Number 7. It says that M is the midpoint of PQ. So what do we know about, and let's see, the diameter is 13 and RM is 4. So this is 4 and this is 9, right? Is that right? Okay, then it says that M is the midpoint of PQ. So that tells me that whatever this is the same thing. So X times X equals 4 times 9. So I get X squared equals 36. You see? Does that make sense?
Yeah. Alright.
But that's all I wanted you to do. Okay.
I'm revoking your galaxy brain license. I'm shifty. Oh, I can do that.
Ready? I mean, are you guys